Hey guys, my name's Corbin Dunn, and this is a walkthrough tutorial in Vectric VCarve on how to create curved inlays doing a VCarve inlay. And it works in VCarve and it also works in Aspire because they're essentially the same tool. Now I strongly prefer to do curved inlays with Autodesk Fusion, and I've got a new plugin that makes it really easy to do. But before I did that, I was doing a few of them with Vectric VCarve. And so this is a walkthrough my method on how I was doing that. Now this process has lots of rough edges and limitations, so it works in my particular cases. Some prerequisites: you should know how to do inlays and get a tight inlay fit with whatever bit you're using. I'm going to be using a 15-degree V bit. I'm not actually going to do the machining, I'm just going to show how I set it up because that's the hard part. So let's jump over the computer and get into it. All right, so inside of VCarve, I opened up a file where I already have a carving, and you don't really see anything. This is my wok spatula design, which I have available for people to download. I'll link to it in case you want to get a copy. But the problem here is I have limit planes, which kind of hide the whole design. So I'm going to go ahead and show it, and you can see, you can actually see what this design is. So let's add an inlay on the top of this 3D model. Go to 2D view. All right, let's do File, Import, and we're going to go ahead and import a vector. And you can do whatever vector you want. It just has to fit within your model. It's down here at the bottom. Go to Design, and let's go ahead and center it horizontally, and then let's hit M for Move, and I'm going to move it to fit here. I'm going to zoom in a bit. And it would go outside my shape here, so that won't work. And it's a little bit big. I'm just going to go ahead and shrink it down just a little bit so it fits within the confines of our shape here. The closer it goes to a vertical edge, the more you will have difficulty machining it. So keeping it sort of inside your bounds is a lot better. All right, so what I should already mention is that this has the cam set up. It just does a roughing toolpath and a finish toolpath. Go to 3D view to go ahead and machine this whole spatula shape. And there's not much to really talk about that, but it is important to understand that it's going to do this. Okay, so let's go ahead and VCarve this area here, the vectors. So let's do a VCarve engraving toolpath. Start depth of 0, flat depth of 100 thousandths. My bit is going to be the Amana 15-degree V bit with a 0.0005 tip. And this is written incorrectly here, it's 005. And I'm not going to talk about feeds or speeds. 1/8 of an inch in mill for clearance. And the trick for V-carving, at least the pocket, well the plug too, but mainly the pocket for right now, project toolpath onto 3D model has to be checked. So this here is checked. Hit calculate, and you're going to get an area that you can do some 3D carving. So I'm going to go ahead and preview it. Let's just preview the finish and the VCarve because that's really what we care about. Cool, so we'd have a pocket, and it looks like we would have some rough areas. My resolution here isn't too good. And that's from the clearance. Now there's some ways to take care of that. You could use a tapered ball nose with a small step over to address that. So let's go ahead and do that. Let's use 1/8 of an inch tapered ball nose with a 1-degree taper. And let's have it have a pretty small step over, like 3 thousandths of an inch. And we can remove the other one. Let's just calculate this now. And so now the clearance is doing a lot more work here. And we can go ahead and preview this again. Let's reset the preview, preview the visible toolpaths. All right, so it gives a lot cleaner of a pocket there, something that could be fine for putting a plug into. So that part's pretty easy. It's pretty easy to figure out the projected toolpath. Okay, for the plug, it is going to be a lot harder. And this is where things get a lot more specific. So we already have the design here and everything's set up, let's go ahead and do File, Save As, and let's save this copy as the plug because we're going to be messing with it quite a bit. All right, so this is way too big for the plug, so let's go ahead and edit the job size and position. We only need single side for this. The width, I want to change the width, but I want to keep everything centered because this one's centered. So I'm going to hit that XY datum as the center. And let's go to 1.25 inches wide. And let's make the height 2 inches. And cool, that gave me a really small piece. Let's make it 2.5. And the thickness, it could be whatever you want. Let's make it 0.75 for 3/4. That should be deep enough for a plug. And now we need to center this, and we will do that in just a minute. I'm going to go back to the bottom left as my origin corner here because that's what I like to use. And hit OK. Unreversible operation. That's cool. And we're not going to calculate toolpaths yet. So we obviously need this to be right at the location of where our stock is, the white circle. So if I select everything, hit M for move, and you have to select everything and move everything at the same time. If you don't, you're going to have your plug get out of sync with the model and it just won't ever fit in. All right, so here the design is within the shape and size of the plug. So that's good. Now, let's go ahead and go to the 3D view. And we still have some tabs from before. So let's go over to Layers, Components, and let's just turn off the tabs. Let's also turn off the limit planes because we don't need them right now. And now what we need to do is we want an inverse of this shape. And it's incredibly easy to make an inverse of the shape. Just right-click on your model in the components, and you can just change its combine to be a subtract. And now you have an inverse of that shape. And that was pretty simple. Now let's go ahead and turn on the stock here. Look at the left side, and let's look at an orthographic view. So it looks like it goes high enough to where we could do some carvings. We might want to be a little bit deeper, so we could add a limit plane to actually do that for us. So let's go ahead and do that. Back over to Design, add a plane with a 0 height, go back over to Components, and I think I added it in my limit planes here. So let's go ahead and hide the other ones. So this limit plane here at the bottom, what it did is, if I turn it off, notice there's nothing at the bottom. Turn it on there, and it filled in the bottom because its combined mode is going to do an add. And so that made it a little bit thicker. If you wanted your model to be higher, you could go here and you could actually reposition things. So if I wanted to actually move my component up, we could go to the properties and we could change where its position is, its base height. We don't want to change its shape height because that will change the actual shape. But its base height we could actually make be taller if we need it to be thicker or smaller. So here, for some reason, since it's since this combine is the subtract, you have to use a negative to make it taller, but we're not going to do that. So back to 0. And that's just an example of how you could customize it, customize the size of this. All right, so you have this shape here that's going to be the shape for your plug, which you'll cut into. So like before, you're going to have to do a 3D roughing and a 3D finish to machine this shape first before you do anything, before you do your inlay. We don't need a drill toolpath. Let's go ahead and delete that. So 3D roughing, let's double click on that. And let's see, we want to not have it machine everywhere. If I just go ahead and calculate this, it's going to go ahead and machine outside, which is just a little too much. We really need the inside of the plug. So let's fix that in the design. So I'll go back over to 2D view. I'm going to select my model, and we want to create an outline of the model. And it's pretty easy to do that. We're going to go down here, create vector boundary around selected components, and it created a vector around the model there, which is awesome. We're going to use that in a couple ways. And let's first use it in the 3D roughing toolpath by limiting the machining area to a selected vector. And I'm going to select this vector here as where it's going to machine the roughing. And this should give a cleaner roughing pass, not cleaner, but more isolated roughing pass. And it looks like it's still going out a bit. And it's still going out because I have a boundary offset. Boundary offset's going to be 0. It's going to leave 20 thousandths for doing my finishing pass. There we go, a lot cleaner toolpath, just doing the inside of the plug. 3D finish, we're going to do the same thing. We're going to limit the machining to the boundary here, and we don't have to go outside of it for this one either. Calculate. All right, so we can go ahead and take a look at the toolpaths that generated, and it looks good. We can preview it. And the important thing to realize here is this is creating a negative shape to fit as your plug. It's the base shape that we can then go ahead and use as a starting point for doing a regular VCarve inlay plug. One of the things I'm noticing is my plug may not be deep enough for this particular case. I might actually have to move it up or make my stock thicker. We will go ahead and try it for now and see how things work. Yeah, let's go ahead and make it thicker right now. So let's go back over to, let's look at this side of it here. Let's go to close the preview, and let's go ahead and make it higher just like we were talking about. So this guy here, right click, go properties, base height, let's move it up 100 thousandths of an inch. And that's a lot higher. So that should help us. We could also make the stock be thicker if we needed. Okay, now we have to recalculate these toolpaths. Okay, so now we need to do the actual VCarve of a plug. And this isn't really going to be a tutorial on how to do VCarving. And hopefully you already know how to do start depth, finish depth, final depth for VCarves. And let's go back to the 2D view, and let's double click on the VCarve, which we had done before. Now for me, for my particular V-bit, I found that 050 is a good starting depth, and about 0.175 is a good flat depth. And we're going to do the same things, the taper ball nose. We're going to do some more tricks in a bit too. And we want to do a plug, so we need an outer boundary. So we're going to select the outer boundary in addition to the inner one. So we're going to just go ahead and select those guys. Calculate. And like before, this has project toolpath onto 3D model, which is one of the essential parts to have it do this correctly. All right, it finished generating the toolpaths, and we can go ahead and take a look at them. Let's do a preview, and let's go ahead and preview everything because we need to preview everything. Preview visible toolpaths. And actually I should reset my preview. And let's do it again. So I made the plug a lot higher in its position, and this will help with being able to carve deeper. We might need a deeper stock for this particular carve. It might be too thin in the back, and if that's the case, we would just make a thicker stock, start with a thicker stock. And here you see these edges are all rough. This is just a ramification of how Vectric does their like voxelization or pixelization of 3D models, and you can't really get around it. You could create a higher resolution model, and that will sometimes help, but I always end up seeing these. And this is one of the reasons that I moved from Vectric VCarve to Fusion to avoid problems like this. And so it's going ahead and carving out the plug, and it's turned out pretty nice. So notice it's got that exact curve shape here that we need. Now it's doing the clearance with the taper ball nose. And there's going to be one more thing that we're going to note once it finishes here. And And really what that node is how the taper ball nose will interact with the edges of things. We can already see it here. Notice that it's not going quite deep enough. It's going to leave a little bit of a ridge here, and that might affect your plug from seating properly. And if it does, I'll show you how to address that. This one looks pretty clean, not a lot of extra junk here, which may make it not seat properly. After you machine this, you'd probably have to cut off the sides here so it could actually fit in. But if this little extra bits here, these little things are causing trouble, there's an easy way to take care of that. And we can right click on the VCarve toolpath and we can duplicate it. And I'm going to go ahead and, let's close the preview. I'm going to go ahead and rename it. We're going to call this the VCarve, we're going to call this the only do clearance, because that's all we want to do. And what we want to do is we want to go deeper. So it's going to start at the same flat depth, and we want to go maybe 30 thousandths more. So a flat depth of, or the same start depth, and a deeper flat depth, like 200 thousandths. And we're going to hit calculate. So here I'm going to go ahead and close this. I have it set to not close automatically. So I wrote only do the clearance because you only want to do the clearance. You don't want to do the V-bit carve of it. And so we already have the simulation done for the other part. Let's go ahead and see what only do the clearance will add to it if I preview that toolpath. So what it's doing is it's coming in and it's going to go ahead and just make the plug be deeper and allow it to seat a little bit deeper. It's going to clear up those areas that were left behind. You could also use a flat bottom bit. It wouldn't hurt. And I have done that before and use this trick to just clean up extra junk. And there you go. You should have a plug that would actually fit in properly. So there are some more things you could probably do to clean up the plug a little bit, like machine outside the boundary a little bit to not have the high ridges on the edge, or you could just cut out with a bandsaw. And this process does work. I've created a lot of inlays with it. So hopefully you take these ideas and create some of your own projects. Thanks everyone.